Hello everyone, this video is part number 2 of MPPSC, that is your Manipur Public Service Commission Assistant Engineer Civil Examination. If you are preparing for Manipur MPSC Assistant Engineer Civil Examination, you can enroll in our course. Our course consists ebook that covers your entire civil engineering portion, both the papers, paper 1 and paper 2. You can check syllabus in our application. Plus you will get question bank that covers your entire civil engineering portion, plus test pass feature. Test pass feature contains 3000 plus mock tests that are for your national level examination which are conducted in India. So this was the feature of our course. You can enroll in our course, link is in the description, or visit our website rankingpediaeducation.com. From there you can visit course section and you can enroll in our course. So question number 51 is mentioned over here. Match list 1 and match list 2. Select the correct answer using the codes given below the list. So list 1 is this side and list 2 is given this side on your right hand side. So list 1 is A option. A1 is doubly reinforced section. B is limit state design. C is minimum cover. D is span depth ratio. We have to match the following with the list 2. List 2 is first is serviceability, second is durability, third is reduction in sectional depth, fourth one is ultimate movement capacity. So coming on to the list 1A, that is your doubly reinforced section. This is connected to reduction in sectional depth. This is connected to which option? That is your third one. A is connected to third one. Why it is connected? A doubly reinforced section is used when the depth of the beam is restricted due to architectural or headset requirement. So a doubly reinforced section is connected to third, that is your reduction in sectional depth. Now we will check the option. So A is connected to 3. So option number B is only correct because A is correctly connected to 3. Now we will check another also. So limit state design. Limit state design is connected to ultimate movement capacity, and your minimum cover is connected to durability. Concrete cover is actually the distance between the reinforced bars and the outer surface of the concrete. So minimum cover is connected to the durability, whereas your D, that is your span depth ratio, it is connected to serviceability, that is your A. So A is connected to 3, B is connected to 4, C is connected to 2, that is your durability, and D is connected to first one, that is your serviceability. Option number B is correct. 52nd question is, as compared to an over reinforced section, an under reinforced section is preferred because options are more economical, B is avoid sudden failure, C is less steel is used, or D option, that is all of the above. So as compared to an over reinforced section, an under reinforced section is preferred because more economical section, and also avoid sudden failure, also less steel is. So option number D, which is all of the above, is correct. Next is question number 53. The joint action of steel and concrete in a RCC section depends upon the, it is you, upon the, your options are bond between concrete and steel bar. B option is absence of cohesion of steel bars embedded in the concrete. Option number C is practically equal thermal expansion of both concrete and steel, or option number D, it is D, it is option number C, and it is your option number D. Option number D is all of the above. Which of the following option is correct? So the joint action of steel and concrete in a RCC section depends upon the bond between the concrete and steel bar, and also upon the absence of cohesion of steel bars embedded in the concrete, also on practically equal thermal expansion of both concrete and steel. Which is correct? Option number D, that is all of the above, is correct. Next question is question number 54. Analysis of reinforced concrete is done by which of the following theory? You have to answer. Your options are given. First is straight line theory, B is elastic theory, C is ultimate load theory, or option number D, which is all of the above. So analysis and design of reinforced cement concrete structures, which is RCC structures, have evolved over time, and all three methods which are mentioned here, option number A, straight line theory, elastic theory, ultimate load theory, all these options are correct. So option number D, all of the above is correct for question number 54. Next one is, for a two-way slab, main reinforcement is provided along the, your options are length of a slab, width of a slab, C option is any direction, and D option is all of the above. The question is, for a two-way slab. So for a two-way slab, your main reinforcement is provided along. You have to answer this. So for a two-way slab, what is actually a two-way slab? A slab is considered a two-way when it is supported on all four edges, and ratio of longer span, which is your Ly, to the shorter span, that is Lx, is less than twice of Ly by Lx, is less than 2. So that is your two-way slab. Okay, so for a two-way slab, main reinforcement is provided along the length of slab, width of slab, and in any direction. So option number D is correct for 55 question. All of the above is the correct option. Next one is your 56. What is the minimum grade of a concrete recommended in reinforced concrete work as per IS 456 is 2000. So minimum grade of concrete which is recommended in reinforced concrete work as per IS 456 is your mild exposure condition, is your M. So option number C is correct. Okay, so as per IS 456 guidelines, according to clause 6.1.2 and table 5 of IS 456 is to 2000, the minimum grade of concrete for a reinforced cement concrete, which is your RCC, under mild exposure condition is your M20. For plain cement concrete, that is for your PCC, your which one is considered? That is your M15. For RCC, it is your M20. This thing you have to keep in mind. Next question is, what is the degree of workability of concrete measured in accordance with IS 1199 for a slum of range 100 to 150? According to IS 456 2000, which incorporates workability measurement standards from IS 1199. So you have to remember the degree of workability, and according with that, slum in mm. So if it is very low, then your slum ranges between 0 to 2.0 to 25. So if it is very low, your slum ranges in mm from 0 to 25. If it is low, then it is from 25 to 75. Here it is the degree of workability. Okay, so here it is the degree of workability. And when we say medium, so medium ranges between 50 to 100, and for high above 100, it is from 100 to 150, it is considered to be high. So the degree of workability is considered to be high. Option number D is correct for 57th question. Next one is your 58th question. What is the basic values of span to effective depth ratio for a simply supported T-beam for a span of 10 meter as per IS 456? According to IS 456 clause 23.2.1, the vertical deflection limits are generally satisfied when the span to depth ratio does not exceed the basic values for span up to 10 meter. For this, your simply supported is, when simply supported is 20. Option number B is correct. The basic value of span to effective depth ratio for a simply supported T-beam for a span up to 10 m is 20. For cantilever, it is 7, and for continuous, it is 26. So 26 is for continuous, and 7 is for your cantilever. Next is 59th question. What is the effective width of a flange for isolated T-beam as per IS 456? Here values are given, like your BF is denoted by effective width of flange. L0, L, or you can say L0 is actually denoted by here distance between the point of zero moment in the beam. BW is the breadth of the web, and DF is the thickness of the flange, and B is the actual width of the flange. So the effective width of flange for isolated T-beam is determined by formula is EF is equals to L0, which is the distance between the point of zero moment in the beam, whole upon L0 by B. Now B is the actual width of the flange plus 4 plus BW. BW is what? Width of the web. So this is the correct formula to calculate the effective width of flange for isolated T beam. Now for isolated L beam, so for isolated L beam, your formula is BF is equals to 0.5 L0 by L0 by B plus 4 plus BW. Okay, so for L beam, this is the formula, and for T beam, this one is the formula. Now we will check the option. So which option is correct? So here option number first is correct. Option number A is correct for 59th question, which is effective width of flange for isolated T beam is option number A is correct. Next question is question number 60. A reinforced concrete beam is subjected to 5 kilonewton meter bending moment due to dead load and 25 kilonewton meter bending moment due to live load. What should be the design bending moment for limit state of collapse? Your option are, so option number A is 30 kilonewton meter, 36 kilonewton meter, 45 kNm and 50 kNm. So moment due to dead load, which is denoted by DL, is given, which is 5 kNm, and moment due to live load, which we will be denoting by LL, is 25 kNm. Now we have to calculate design bending moment. So for this, your formula is mu 1.5 into, in a bracket, DL plus L, which is your sum of dead load plus sum of moment due to live load into 1.5. 1.5 to DL, which is 5, plus LL is 25. Here 1.5 into 30, which comes out to be 45 K. Which option is correct? Option number C is correct, which is 45 to Newton meter. This is the final answer. This is the design bending moment for our limit state of collapse, which is 45 kNm. Option number C is correct. Next question is question number 61. In a limit state design, what is the length of rectangular stress block in a stress block diagram where XU is neutral axis depth? Your option are 3 by 7 XU, 4 by 7 XU, 3 by 4 XU, or 1 by 2 XU. So total depth of neutral axis, which is denoted by 4 XU. So depth of parabolic portion, which is your x1, by 0.002 is equals to x by 0.0035. Why? Because rectangular part, the strain in concrete is between 0.002 and 0.0035. Here comes out to be x1 is equals to, now if you will calculating this, so x1 you will get 4 by 7 of xu. Here now we will calculating depth of rectangular portion. So this is your x1 is what? X1 is depth of parabolic portion. Parabolic portion. And we have to calculate the depth of rectangular portion. Now we will be denoting this by x2. We will be denoting this by x2. X2 is x mu, that is your xu, which is your neutral axis depth, minus 4 by 7 of x. Xu minus x1 is your x2, which is your depth of rectangular portion. So x2 is what? Depth of rectangular portion. X2 is x. So if you will solve this, x2 minus 4 by 7 of, get the answer, 3 by 7 of xu. 3 by 7. So which option is correct? Option number A is correct. That is 3 by 7 of xu. Next question is question number 62. The value of design bond stress in a limit state method for a bar in compression is increased by how much from the bar in tension? Your options are given, which is 15%, 25%, 40%, or 60%. So bar in compression, so bars compression. So design bond stress values for bars in tension are increased by 25%. Option number B is correct. Next question is question number 63, which is the ultimate moment resisting capacity of simply supported pre-stressed concrete beam using is obtained by using, option is force and moment equilibrium equation, is stress strain relationship of concrete and steel, option C is moment equilibrium and compatibility condition, option D is force equilibrium equation alone. So which one is the correct? So that is your stress strain relationship of concrete and steel. Option number B is correct. Next question is question number 64, which is your in pre-stressing scheme, pre-stress load is transferred in which process? Your options are given, single stage process, multi-stage process. Option C is either single or a multi-stage process depending upon the magnitude of load transfer. Option D is the same manner as in post-tension scheme. Post-tensioning scheme. So which one is the correct? So in a pre-stressing scheme, pre-stress load is transferred in either single or a multi-stage process depending upon a magnitude of the load transfer. So option number C is correct. Next question is question number 65. The propagation of a shear crack in a pre-stressed concrete member depends upon which factor, which reinforcement. Options are given, tensile reinforcement or compression reinforcement or a shear reinforcement or on the shape of the cross section of the beam. So which one is the correct? So propagation of a shear crack in a pre-stressed concrete member depends upon shape of cross section of the beam, because is significantly influence how shear cracks propagate in a pre-stressed manner. Option number D is correct. Next question is the magnitude of loss of pre-stress due to relaxation of stress is in which range? So the standard range for this is from 2% to 8%. Now let's check the options. So options are given. Option number 1, 0 to 1. Option number B is correct over here. That is 2 to 8%. Next Question is question number 67, which is your in an RCC beam side face reinforcement is provided if its depth exceeds. So option number D is correct, which is already takes, that is 750 mm. Next question is lateral ties in RCC columns are provided to resist. The option is tick. Options are given also: bending moment, shear, buckling of longitudinal steel bars, or both bending moment and shear. So generally in our reinforced cement concrete, that is your RCC column, the main vertical bars are under heavy compression. So without lateral support, these long thin bars would easily bow or buckle outward under the load. So which of the following option is correct? That is your buckling of longitudinal steel bars. Option number C is correct. Question number 69th is according to IS 800, what is the maximum slenderness ratio of compression member carrying both dead and live load? Which of the following option is correct? Your options are given: 180, 200, 250, or a 350. So you have to tell maximum slenderness ratio, which is denoted by this. Okay, this denotes maximum slenderness ratio. So what kind of member for this? So a member carrying compressive loads resulting from a dead loads and a imposed loads, which is live load, generally is in 1. So maximum slenderness ratio is 180 for this. Option number A is correct. Next question is according to IS 800, what is the value of imperfection index in a merchant Rankine formula? So which one is the correct? So the index, the value of empirical constant is taken as 1 point. Option number B is correct. Next question is question number 71. A strut is a structural member which is subjected to which of the following option is correct? Option number A is tension in direction parallel to its longitudinal axis. Option B is tension in direction perpendicular to its longitudinal axis. Here it is parallel, here it is perpendicular. Option C is compression in a direction parallel to its longitudinal axis. Option D is compression in a direction perpendicular to its longitudinal axis. So a strut, what is actually a strut? So it is a structural component which is designed to resist longitudinal compression. Designed to resist longitudinal compression. Which of the following is correct? So a strut is a structural member subjected to compression in a direction perpendicular to its longitudinal axis. Option number C is correct. Question number 72 is the axial load which is sufficient to keep the column in a slight deflected shape is called. So it is called, options are given: critical load, crippling load, buckling load, or all of the above. So these terms like your critical load, crippling load, and buckling load, what they describe all the physical phenomenon. Which of the following option is correct? The axial load which is sufficient to keep the column in a slight deflected shape is critical load, crippling load, and also buckling load. So all of the above option is correct. Option number D is given. Option number D is correct. Question number 73 is angle of inclination of the lacing bar with longitudinal axis of the column should be between. Your option is, ranges are mentioned, that is from 20 degree to 30 degree. Option B is 30 degree to 40 degree. Option C is 40 degree to 70 degree, or D, which is 90 degree. So the angle of inclination of the lacing bar with the longitudinal axis of the column should be between 40 degree to 70 degree. Option number C is correct. So next question is question number 74. Shear buckling of a web in plate girder is prevented by using, your options are vertical intermediate stiffener, horizontal stiffener, option C is bearing stiffener, or D, that is all of the above. So shear buckling of web in a plate girder is prevented by using which kind of stiffener? To answer, so in a plate girder, the thin web is susceptible to different types of buckling. Okay, stiffeners are used to provide stability. They are used to provide stability and also increase the load carrying capacity of the web. Shear buckling of a web in a plate girder is prevented by using vertical, or you can say transverse intermediate stiffeners. Option number A is correct, because vertical intermediate stiffeners are used to prevent shear buckling of the web. Option number A is correct. Next question is question number 75. Lacing provided for a compression member shall be designed to carry a transverse shear which is equal to, your option are given, 2.5% of axial force in member, or 5% of axial force in member, or 7.5% of axial force in member, or none of the above. So transverse shear is taken as at least 2.5% of the axial force in a member with the formula Pt is equals to 0.025 P. From here, so 2.5% option correct. Option number A is correct. Next question is question number 76. In a plastic analysis for flexure, which of the following pair of shape of section and shape factor are correctly matched? So here I is with 1.4. I is what? It is I section. Same square section is with 1.8. Rectangular section is 1.5. Circular section is 1.7. What we have to do? We have to select the correct answer using the codes which are given below. Option A is 1, 2, and 3 are correct. So you can say these are generally statements. The first statement is I section denotes 1.4. Square section denotes 1.8. Rectangular section denotes 1.5. Fourth statement, which is circular section, denotes 1.7. Option B is 3 and 4 are correct. Option C is only 3 is correct. Option D is 1, 2, and 4. All of the 4 statements are correct. So I section, so the shape factor for standard I section ranges from, so for I section, your standard I section ranges from 1.12 to 1.15, and here it is with 1.4. This statement correct. So coming on to the square section, so for a square section, the specific type of rectangle, its shape factor is 1.5. So shape factor is here 1.5 for your square section, and here it is given 1.8. So it is also incorrect statement, you can say. For rectangular section, now for rectangular section, the shape factor for rectangular section is 1.5. So it is correct. So third statement, you can say it is correct. Now coming on to the fourth statement, so circle is with 1.7. Now for a solid circular cross section, the shape factor is approximate 16/5, which when you will calculate, which will be approximate 1.7, round of 1.7. So yes, fourth section is also correct. Fourth statement is also correct. So which of the following option you will take? That is your option number B. 3 and 4 are. Next question is question number 77. As per BIS 800, the maximum bending moment for a design of continuous pure lines can be taken as, your option are given, WL/6. M is what? M is your bending moment, and here your options are given, WL/6, WL/8, WL/10, or WL/12. So what is actually WL? So W is total uniformly distributed load on the purlin. Okay, on the purlin, so total uniformly distributed load is denoted by W here, and L is the distance between the centers of the support, or you can say the distance between the centers of the rafters, you can say. Okay, As per BIS 800, the maximum bending moment for a design of continuous pure lines can be taken as WL by 10. Option number C is correct. Next question is question number 78. The economic spacing of roof truss depends upon, your options are cost of purlins and cost of roof covering, dead load and live load and cost of purlins, or option D, which is live load and cost of roof covering. So the economic spacing of roof truss depends upon cost of purlins and cost of roof covering, which is T is equals to plus P plus R. Here T is your cost of truss, P is your cost of purlins, and R denotes cost of roof covering. Okay, so this thing you have to keep in mind. So option A is correct, cost of purlins and cost of roof covering. Next question is question number 79. In a truss girder of a bridge, a diagonal consists of milled steel flat 400 ISF and carries a pull of 800 kilonewton. If the gross diameter of the rivet is 26 mm and part driven, then the number of rivets required in the splice. So we will note down the given data one by one. So first is what is given? 400 and 800 kilonewton, which is your pull is given, pull load down, given data. What is given? Pull is given, just 800 kilonewton. Then what is given next? Next is your gross diameter of rivet is given. Gross diameter of rivet. Gross diameter of rivet, which will be denoting by small d, equals to, value is given, value is 26 mm. Value is, now what we will be doing? So we will first find out type. So power driven shop rivets, we will be assuming this. So permissible shearing stress, which is F is equals to 100 MK or Newton per millimeter square, and permissible bearing stress is divided by N 300 M. So we will be calculating what? First we will be calculating shearing strength. First we will be calculating shearing strength. P twice of pi by 4 square permissible shearing stress, which is shearing stress is equals to twice of pi by 4 d square. Now d is what? Gross diameter of rivet, 26 square 100. What this is for permissible shearing stress. Is your permissible shearing stress. Okay, 200 2 into pi by 4 to 26 whole square. So pi by 4 to what into, we will calculate the value which is 26 whole square. So 26 whole square is 676. So value will be coming around 106.19 kilonewton. We have found out value. So shearing stress value is 106.19 kilonewton. Now what will be calculating? We will be calculating bearing strength. Bearing strength will be denoting this by PB. Bearing strength by. Okay. Now fourth one is your, we have to calculate number of rivets. Number of rivets. Also find out of rivets, which will be denoting by small n, and it is total pull by a rivet value. Total pull is 800 kilonewton. Just mentioned over here, total pull, which have denoted, we have denoted by P. You can denote it by P over here. Okay, by P you can also, or just you can write pull. Total pull is 800 kilonewton, and rivet value is over here, that which is 106.19 kilonewton. When you will divide 800 by 106.19, will become approximately 7.53, or you can say approximate 8. Now we have to check the option. So option number 7.5 is greater than 7. So yes, we taking on option number, this option number 8 is correct. Next question is question number 80. Collapse load for a fixed beam with a central point load is. So we have to find out for a central point. For this, first we will be identifying plastic hinges. So for a fixed beam of length L with a central point load W, can say we will be denoting central point load. Point load we have denoted by W, and fixed beam length, beam of length, fixed length by L. Now we will be applying virtual work principle. Now on applying virtual work friction, so let the beam undergo a small virtual displacement, will be denoting by this under the load if the rotation at the support is theta. So if the rotation at the support is theta, the rotation at the center hinges will be, rotation at center hinge will be twice of theta. Okay, now from here your external work done, which will be denoting by WEXT is what? Work is load into displacement. Load into displacement, W into displacement, you have denoted by, this is your external work done. Since your displacement is L by 2 theta, external work done will be W into L theta by 2 for external work done. Now we'll be finding out internal work done. So for internal work done, we have denoted this by W. Internal work done, what will be, how will be finding out? So MP at support A plus moment at center, or you can say at center C, will be twice of theta, plus at end theta, or at support B. This is moment at support A, this is at center, if it is twice of theta, this is moment at support B. W internal, which is for Work done internal is theta plus twice of theta plus theta, which is 4 times of theta. Now here, what is MP? Plastic moment. It represent what? Represent your plastic. So we have calculated external work done. We have also calculated internal work done, which is 4 times of plastic moment. Now we will be equating external and your internal work. So final is your on equating internal work done W ext 2 is your W external work done to work done internal. W external work done is W into L theta by 2, and your internal work done is 4 times of M theta. From here, W 4 times of theta 2 whole upon L theta out. W is 8 of I. This is the final. The collapse load for fixed beam with the central point load is 8 by L. So which option is correct? Option number A is 8 m by L. Next question is question number 81. Which of the following mode of failure is taken care of in a plastic design of steel beam? Your options are mentioned: plastic material deformation throughout the beam, or hinge formation in the beam due to yield stress. Option C is mentioned, which is elastic buckling of the beam, or D, none of the above. So which of the following mode of failure is taken care of in plastic design of steel beam? So for a plastic design of steel beam, your plastic hinge formation, mechanism of failure. So these are the important concept. So which of the following option is correct? That is your hinge formation in the beam due to yield stress. Option number B is correct. Next question is the permissible stresses for main structural steel members, the dynamic loads should be increased by how much percent? Your option is mentioned: 11.11%, 22.22%, or 33.33%, or none of the above. So for main structural member, the increase is 1/3, which is for 33.33%. For connection like your rivets, bolts, the increase is typically 25%. This thing you have to keep in mind. So option number C is correct. Next question is, in the case of an axially loaded column machine of full bearing, the fastening connecting the column to the base plate as gusset base are designed for. Your option is mentioned: 100% of column load, 50% of column load, 25% of column load, or none of the above. So when a column end is machined for full bearing, what does it mean? It means the end of column is ground flat so that it makes direct contact with the base plate. Okay, so none of the above option is correct. Option number D is. Next question is question number 84. If P is the basic wind pressure for building with large opening design pressure on a wall is taken as, your option is 0.5 p, 0.7 p, 1.0 p, that is 1 p, or 1.2 p. So in structural engineering, wind pressure on a surface is calculated by considering your external and your internal pressure coefficient is denoted by, internal is denoted by C. Internal pressure coefficient is denoted by C. Okay. So if P is the basic wind pressure for building with large opening design, pressure on wall is taken as 1.2 P. Is 1.2 basic wind pressure. Option number D is correct. Next question is, an equipment is available for rupees this much. An equipment is available for rupees 2 lakh. It has an estimated useful life of 5 years. By the double rate declining balance method of depreciation, the book value at the end of second year will be. So we have to find out the book value at the end of second year will be. And here your options are mentioned. We will be calculating this also. So what is given step by step we will be calculating. First we will be determining what? First we will be determining the depreciation value. Depreciation rate we will be determining. So straight line rate is 4 1 by useful life, which is useful life for 5 years, is 1 by 5, around percent. Depreciation rate is 3%. Second, we'll be finding out year 1 depreciation. Here for first year depreciation. Opening book value given, so value is 2 lakh. Depreciation is lakh to 0.40, which is approximately 80,000. Okay, so book value at the end of 1 year, for how we'll be calculating? Opening book value minus depreciation. So book value at end of year 1 book minus of depreciation. Yes, you minus 1 lakh. This is the value of book value at the end of 1 year. Third, we will be finding out year 2 depreciation. Year depreciation. So year 2 depreciation, opening book value. Now for year 2 depreciation, your opening book value is, so for year 2 depreciation, your opening book value will be your book value at the end of first year, which is 1 lakh 1000. Next is your depreciation. Depreciation is 1 lakh 20,000 into 0.40, which is 40,000. Next one, book value at the end of year 2. Book value at end of year 2. How we have calculated for year 1? Is opening book value at year 1 minus depreciation at year 1. For this, book value at the end of year 2 calculated by opening book value at year 1 at year 2, book value at year 2 minus depreciation. So 1 lakh 20,000 minus of 48,000, which is approximate is 70,000 value. So value is 72,000. So the book value at the end of year 2 will be 72,000. So which of the following option is correct? Option number is 70,000. Option number C is correct. Next question is question number 86. So question number 86 states 6 cubic meter RMC plant takes in 1875 kilogram of cement, 5,120 kilogram of sand, 6,060 kilogram of coarse aggregate, along with 865 kilogram of water per patch. There is a reduction of 1.5% in volume. The fresh mixed wet concrete from the nominal volume. The unit weight of freshly mixed wet concrete will be. So we have to find out the unit weight of freshly mixed wet concrete. The next question is question number 86. 6 cubic meter RMC plant takes 1875 kilogram of cement, 5,120 kilogram of sand, 6,060 kilogram of coarse aggregate, along with 865 kilogram of water per patch. So there is a reduction of 1.5% in volume in the fresh mixed wet concrete from the nominal volume. The unit weight of freshly mixed wet concrete will. So what we have to find out? We have to find out the unit weight of freshly mixed wet concrete. So here what is given? 6 cubic meter RMC plant. R plant. How much what we had taken? Cement is 75 kilogram. Gram. Next is sand. Sand is 5,020 kilogram quantity. Coarse aggregate, which is 1,060 coarse kilogram. Water is 805 kilogram, and also there is a reduction of 5% in volume. So what we have to find? We have to find out unit weight of freshly mixed wet concrete. So how will we be calculating this? First, we'll be calculating total mass of concrete. Total of first step is calculating total mass of concrete. So how will we be calculating total equals to mass of cement, which is 5, plus mass of sand, which is 5,120 gram, plus mass of coarse aggregate, which is 1,060 kilogram, plus mass of water, which is water per patch is 5 kilogram. What we have, what will be getting the value? 2 13,920 kilogram is the total mass of concrete. Now what we will finding out? We will be calculating. Next step is calculating actual volume of concrete. We have to calculate actual volume of concrete. For this, actual volume equals to nominal volume minus 0.5% of So nominal volume is 6 meter cube minus 1 minus 0.015, which is 6 to 1 minus 0.015 is 2.5. Actual volume we have got, well, volume we got, when you will multiply 6 into 0.985, you get the value 5.91 meter cube, the value of actual volume. Third step, we calculating what? We calculating unit weight. Weight is equals to total mass whole upon actual volume. So total mass we have calculated. Here it is mentioned 13,920 kg. Okay, so 13,900 kilogram is the total mass, and actual volume we have calculated 591 meter cube. Here it is. So when you find out any value mentioned, the full unit kg is, it is 13,920 kilogram by 5.91 meter cube. When you will calculate, so you can use calculator. So I am using the calculator right now. 2355.33 kilogram per meter cube. Approximate value is 2355.33 kilogram per meter cube is the unit weight volume. So unit weight, we can say the value is approximate 2355 kilogram per meter cube. Weight we have calculated, which is 2355. Here option number C is correct. 2355 kilogram per meter cube. Next question is self-loading scraper is, option is reduce loss in power, lower rolling resistance, or comprise between loading and hauling performance, or none of the above. Self-loading scraper compromise loading and hauling performance. Option number C is correct. Self-loading scraper is designed to load itself. Without the need of pusher tractor. Load itself without the need of pusher tractor. Okay, which of the option is correct? Self-loading scraper compromise between loading and hauling performance. Next question is, in a project, the contractor is paid on the basis of running bill for a month. The rate contractor for concreting is 5,000 per meter cube of concrete. The consumption of number of cement bags of weight 50 kg is 527. The mixed proportion is 1 is to 1.5, 1.4 is to 2.75, with WC ratio as 0.52. WC ratio is also given, which is 0.52. So the approximate billing amount for the month will, we have to calculate the approximate billing amount. So we have to calculate approximate billing amount for the month. Okay, so we will note down one by one value which is given. What value is, like here you can see weight of 1 bag of cement is given 3 kg. Weight of 1 bag of kilogram. Volume of one bag also given, and that is your approximate value is given. Density, so volume is also given. Bag of cement is approximately 0.7 meter cube. Why? Because the density for this density is 1440 kilogram. So volume of one bag of cement is 0.0347 meter cube. Mixed proportion is given. Mixed proportion is given. This one here you can see given 1 is 1.4 to 2.75. Add on this 1.4 to 5. Add all this part 1 this 5.15 is total value of. We'll be calculating volume of concrete per bag. How will you calculate this? Volume of, here step 1 starts. Step 1 we will be calculating volume of concrete per bag. So volume of one bag into sum of proportion. I have calculated sum of proportion whole upon shrinkage factor. Here volume of one bag is 0.7. Sum of proportion, or you can say sum of mixed proportion, is also given 5 whole upon shrinkage factor. Shrinkage factor is given or not? Shrinkage factor is 1.54. So after calculating this, you can use calculator over here. Volume of concrete per bag will be approximately 0.2 meter cube. Okay, first step is you calculating volume of concrete per bag. Second step number is total volume. How many bags are mentioned? Total bags are mentioned 527. Total volume for 527 bag be 520 by 0.11 meter cube, which is approximate 61.1 meter cube. This is the total volume for 527 bag, and that is your 61.132 meter cube total volume for 527 bag. Step number 3 is billing amount. So how will you calculate billing amount? So how will you calculate the billing amount? The billing amount is for total volume into rate. Now total volume here is, so we have calculated total volume. So total volume is 1.1 meter cube rate. Now rate is mentioned over here, rate of contract, which is 5,000 per meter cube. 5,000 per meter cube. Okay, per meter cube the rate. Billing amount, what the value is 1.15,000, which is approximately 3 lakh approximate, 3 lakh 5,660 rupees. The billing amount. Which of the following option matches 3 lakh 5,000, lakh 5,000? None of the above option is. Option number B is correct. Yes. Next question is question number 89. Is batching refers to, your options are controlling the total quantity at each batch, is controlling the quantity of each material into each batch. Option C is water correction batch, or option D, all of the above. So what is actually a batching? Batching is a process of measuring out all necessary ingredients like in cement, coarse aggregate, fine aggregate, water, in order to make concrete, either by weight or by volume. So it is actually a process of measuring out all the necessary ingredients for making concrete by volume or by either weight. So batching refers to controlling the quantity of each materials to each batch. Option number B is correct. Next question is question number 90. It is desired to purchase 4 different types of construction equipment from 3 different manufacturers. The optimal order for the equipment and the minimal cost are to be determined. Most appropriate model for this purpose would be, your options are, which method satisfy these conditions. First is waiting line method, or option B is inventory method. Option C is transportation model. Option D is assignment model. So according to the situation, involves 2 sets of data. As you can see in the question, requirement is 4 different type of equipment. Okay, here 4 different type of equipment. Availability or source are 3 different manufacturers. So here is option number D is correct. That is your assignment model. Option number D is correct. A special case of transportation model used to assign n tasks to m resources on a one-to-one basis is your assignment. As we can see, 4 different types of equipment is there and resources are 3 available. That is 3 different manufacturers are. Option number D is correct, which is assignment model. Next question is question number 91. The optimistic most likely duration and the pessimistic time estimate network are 4-5 months respectively. The expected time is, so here you can see time is mentioned, that like your optimistic time is denoted by what is mentioned, and your most likely time mentioned by TM is 5. Next is your 8 month as mentioned, 8 month is your pessimistic time. Pessimistic time by what we have to calculate, the expected time we have to calculate. So for calculating expected time, formula is not plus 4 times of m whole upon, you can use calculator over here, or without calculator you can also solve. T naught value 4 plus 4 times of Tm 5 plus T, here can get plus approximate value, you will get 32 5 point of the following option correct. But P is correct. PE, which is expected time, is 5.33 months. Next question is question number 92. The probability distribution taken to represent the complete time in PERT analysis is, option is gamma distribution, normal distribution, beta distribution, or all of the above. So what is PERT? PERT is program valuation and you PERLS stands for evaluation, program evaluation and review technique. So the probability distribution taken to represent the completion time PERT analysis is your beta distribution. Option number C is correct. Because it is flexible, because beta distribution is flexible and can account for the uncertainty in your optimistic time, in your likely time, your pessimistic time, which is PP. Next question is question number 93. Cost of owning the equipment would include, options are given. The cost of owning the equipment would include cost of investment, the repairs and depreciation. Is most important. Option number C is correct. Next question is question number 94. Sensitivity analysis is a study of change in output due to change. Option number C is correct. Next question is question number 95. Number 95 is grader used mainly for. So grader is mainly used for finishing, trimming and option number D is correct. Finishing in order to create the final smooth surface for roads or foundations, trimming for cutting material to achieve a specific elevation, and shaping is for grading the ground to a specific profile or specific slope. So grader is used mainly for all these things, these three main modes, that is your finishing, trimming and shaping. Option number D is correct. Next question is question number 96. The most suitable equipment for compacting cohesive soil. For compacting cohesive soil, the suitable equipment is your sheep foot roller. Why sheep foot roller? Because cohesive soil like your clay are best compact using sheep foot roller, which is also known as your pad foot rollers. Okay, these rollers have what? These rollers have your feet that penetrates the soil layer to provide deep compaction through a kneading action and also a high pressure. Sheep foot roller is the best suitable equipment for compacting of cohesive soil. Now, example of cohesive soil is. Next is question number 97. Gantt chart. Gantt chart indicate, what does it indicate? So Gantt chart is a visual project management tool that displays your task against a timeline. So Gantt chart indicates comparisons of actual progress with the scheduled progress. Option number A is. Next question is question number 98, which is in resource leveling. What happens in resource leveling? Your option are total duration of project is reduced. Option B is total duration of project is increased. Option C is uniform demand of resource. Option D is cost of project is controlled. So resource leveling is what? It is actually a technique used in your project management in order to resolve resource over allocation or conflict. So in resource leveling, uniform demand of resource is option number C is correct for this question. Next is question number 99. In time cost optimization of a project, crashing is done. The options are on all the activities. Option B is on all the activities lying on the critical path. Option C is only on activities lying on the critical path and having flatter cost slope. Option D is only on activities lying on the critical path and having steeper cost slope. So in time cost optimization of a project, crashing is done for what? So it is done for mainly only on activities lying on the critical path and having flatter cost. Critical path is the longest sequence of activities in a project, and through this we can determine the total project. This thing you have to keep. So option number C is correct. Next question is question number 100. So here three statements are given, one are given. Consider the following statements: the critical path in a network of a project. Now read these three statements. First statement is helps in planning efficient time schedule. Second statement is indicates shortest path in time. Third is helps in crashing project. So the critical path a network of a project helps in planning efficient time schedule. It is correct. It indicates shortest path in time. It is incorrect. Why it is incorrect? Because the critical path is actually the longest path. It is not the shortest path. The longest path to a project network in terms of duration. So second statement is not correct. So here first only A or D option can be correct. Now we will be reading third statement, which is helps in crashing the project. So the critical path in a network of a project, does it helps in crashing the project? Yes, it helps crashing the project. Crashing refers, what does crashing mean? Crashing means shorting the project by adding more resources. Shorting project by adding more resources. So first statement is correct, second and third statement is correct. Second statement is not correct, and this is not mentioned in any of the option given below. So option number D, which is none of the above, is correct. This was all about Manipur MPSC Assistant Engineer Civil Examination. Enroll in our course. Visit our website rankingpediaeducation.com or install our application Ranking Pedia Education from the Google Play Store. Link is given in the description. Thanks for watching.